Welcome to the Internet of Digital Twins, a genetic IoT platform for mission readiness management. I'm Kent Colling, founder and CEO of BluEyeQ. In this tech talk, I'll present BluEyeQ's digital twin technology, which has the potential to foresee machine failures before they occur. Consider the benefits to the Navy's mission readiness if you can actually predict and foresee failures. Maintenance can be scheduled in advance, which leads to operational efficiency. The potential for catastrophic failure is reduced, and in the case of naval aircraft in flight, this implies improved pilot safety. Our approach is feasible and very exciting. So what exactly is a digital twin? By BluEyeQ's definition, a digital twin is a virtual model-based representation of a physical system used to predict and prognosticate potential outcomes. In short, it is a tool where we ingest or simulate data from multiple input types, do a whole lot of math to extract salient features, and combine those features into a decision-making algorithm for predicting a machine's condition. BluEyeQ, based in Charlotte, North Carolina, was founded in 2013 to reveal the vision, the I, and intelligence, the IQ, in machine data. As the founder, the blue was added in acknowledgement to my highly intelligent and beautiful blue-eyed wife, who without her unwavering support, BluEyeQ would have never become a reality and growing 10 years later. Analogous to a machine doctor, BluEyeQ senses a machine's vital signs, diagnoses machine condition, and communicates the results to the end user in a meaningful manner. Commercially, BluEyeQ provides machine reliability as a service. Elements of the digital twin are used to enable our data analytics team to remotely collect sensor data, primarily vibration, and fuse that information with machine operating condition to assess equipment health. We are an industrial Internet of Things solution provider and have a sensor-agnostic wireless data platform for collecting, analyzing, and communicating customer results. All BluEyeQ SBIR projects have direct dual use for both government and industrial customers. Our Phase 2 work is focused on the V-22 prop rotor drivetrain, but we have existing commercial customers in steel manufacturing, roller coaster monitoring, plastics production, high-performance racing, and university facilities. Our digital twin development has direct application to all customers. Improved overall operational readiness and reduced total cost of ownership are the primary objectives of our SBIR research topic. NAVAIR is the sponsoring command, but our technology has application to NAVC, Army, and virtually any rotating equipment across DoD branches. We formed a great working relationship with the V-22 Osprey FST team at Cherry Point, North Carolina, and have focused our applied research efforts on the V-22 prop rotor gearbox. This approach allows us to bound the problem domain and provide short-term value to the Navy. With that said, we always want to explore new opportunities and bring in new platforms to extend the robustness of our technology. What is the operational challenge? I think this chart on the slide from the Defense Acquisition University paints the picture. 60 to 80% of the total cost of ownership on DoD assets is in the sustaining maintenance. And I've heard this 80% sustainment number stated multiple times by DoD speakers. The opportunity for improvement is clear. Digital twin operational foresight can help reduce costs and improve fleet readiness. The anatomy of a digital twin. How does our technology work? The illustration on this slide shows 3 parallel computation paths for machine trait extraction: reactive maintenance, predictive monitoring, and prognostic statistics. Reactive maintenance is unfortunately how many systems work today. You run the machine to failure and do post-mortem data analysis. Or you have basic detection systems such as a chip detector, which alarms when metal chips are in the lubricant. Well, if you have metal shavings in your oil, something is already wrong, and in the case of an aircraft, this could mean an immediate forced landing. Predictive monitoring is more traditional machine condition assessment, where you calculate, based primarily on vibration, bearing fault frequencies, gear mesh frequencies, shaft alignment, and other key characteristics. These techniques are very powerful given that you have the data for predicting early-stage failure. Prognostic statistics is where we factor in historical machine operating conditions for calculating load impact on system components calculating lubricant effectiveness, and using these parameters to assess suboptimal and overoptimal machine operation. Key traits from all three paths are normalized and fed into a learning and evolving pattern matching algorithm to make a decision of condition. The results are displayed on a 3D modeled representation of the machine components. Real-world data is not always readily available, thus we are building in methods for scenario and profile data simulation. This lets us inject faults into the system for overall robustness. Currently, we are approximately 60% through the base Phase 2 project. Our development approach is highly iterative, where we build out foundational software components such as database schema, efficient data handling services, data analytics services, and user interface components. We incrementally add system components until we get to our end objectives. The resulting delivery is a standalone browser-based software tool that can be used for post-data collection analysis, streaming data analysis, and scenario planning. This tool is still in development, and we expect TRL 4 to 5 capability by the end of this year. We proposed a Phase 2 option year for continued iterations and introduction of additional Navy assets into the model. The additional year will result in a TRL 5 to 6 capability. A key innovation of our technology is the fusion and learned correlation of multiple inputs from seemingly unrelated data. The result is vision and intelligence from machine data, which provides foresight. Foresight benefits include an assessment of optimal machine operating conditions for extended life, predictable maintenance, done when it is needed and on targeted components, and then overall reliability, where machine faults are proactively detected potentially months in advance of any real defect. For fleet transition, our current focus is on rotary wing aircraft. The V-22 PMA-275 is our initial analysis airframe. The helicopters such as the H-1 PMA-276, the H-60 PMA-299, and H-53 PMA-261 are clear candidates for technology adoption. Alternate Navy platforms such as submarines, surface ships, and facilities management are all candidates of our technology. The STP program has been a terrific avenue for us to make acquaintances and identify specific PMAs where transition would benefit from our technology. Frankly, as a small business, we don't have the resources to connect all the government procurement dots, so the assistance is much appreciated. BluEyeQ only pursues dual-use SBIR topics. We utilize data from our commercial customers to prove our digital twin models and make improvements to our commercial offerings. We have a rapidly growing presence in the steel industry for monitoring critical mill gearboxes and supporting secondary equipment such as pumps, fans, compressors, and motors. We have a major amusement park customer where our wireless sensing solution is deployed on multiple attractions and scaling to more rides every year as capital funds become available. Though we manufacture and sell the data collection hardware, our data analysis services provide a growing and compounding revenue stream. All deployments use elements of our digital twin technology. We'll continue to build FST relationships for access to data and validation of our technology. Phase 3 transition to TRL 6 through 8 will require additional funding targeted to specific airframes and program opportunities. Since a digital twin is a learning platform, more data yields more robust results. We are pursuing additional platforms in parallel with our commercial activities to grow the data repository. A mentor-protege partnership with a prime contractor is of interest and an avenue we are exploring. Thank you for your interest in BluEyeQ's digital twin technology and listening to this tech talk. It's an exciting time at BluEyeQ. We are optimistic about the lifecycle improvement outcomes we can achieve for the Navy and all of our customers. Please feel free to contact me with any questions you might have.